Hello everyone, good morning. Welcome back to my channel Learn Tech with Kiran. In today's session, we will discuss most important topic in theory of computation as per university exam, GATE preparation and competitive exam, which is derivation and its type. So basically LMD and RMD are both types of your derivation. Okay, LMD is nothing but a leftmost derivation and RMD is nothing but a rightmost derivation. Okay. So let's discuss about what is meant by derivation. In previous lecture, we designed context-free grammar. Now, derivation is the process where you design a string from your given grammar. It is a step-by-step process where you substitute our production rule or a given context-free grammar for a string generation. Okay. Now, derivation are two types, or you can say there are two order of a derivation. Okay. So first is nothing but a leftmost derivation and second one is nothing but a rightmost derivation. Let's discuss what is mean by leftmost derivation. When each step the leftmost variable or a non-terminal is replaced is called as leftmost derivation. Then what is mean by rightmost derivation? In every step while we deriving a string, we replace rightmost variable by terminal or a symbol. This is nothing but a rightmost derivation. Let's take a look of example for better understanding. So let's consider this grammar, and from this grammar we have to generate a specific string with the help of leftmost derivation and rightmost derivation. Now let's discuss a LMD process then. We substitute our leftmost variable with a symbol or a terminal. Okay, so here you can see for generating a string AA, BB and AA, we have to use this grammar and we have to derive this string with the help of leftmost derivation order. Okay, as your starting, here you can see your starting symbol are S. Okay, now A and S. Okay, in this case your A is a terminal, this A is a your non-terminal or a variable and S is nothing but your non-terminal or a variable. For deriving this string we have to substitute in this way, so you can generate this string from this grammar. Okay, so basically if I substitute this S with A, it is not deriving a string which is AABB A. Okay, so that's why we have to use our first grammar as a initial point or a starting point. So that's why I am writing this over here. Now as per leftmost derivation, I have to substitute my leftmost variable first. So that's why I am substituting this A with a SBA, which is a third rule. Now why I am replacing this A with SBA or a third rule? Because I want to generate a string AABB. Okay, if I am replacing this A with a BA, it is not properly generate this string. Okay, so that's why I am going to substitute this. Now in next step, what I need over here, after A I have to generate a again. Now I am checking for by using which production rule I able to generate a over here. As per second rule, I am able to generate A with the help of this S substitution. So that's why in next step I am substituting this S with A by using second production rule. Okay, so basically my string is generated A B and this A which is non-terminal and this is S which is non-terminal is as it is. Now after this I have to generate again BA. Okay, so basically I am going to check which grammar or which production rule gives me a substitution for B. Okay, so that's why I am checking in A substitution. So here you can see from this three production rule number 5 is having a B and A in it. Okay, so that's why I am going to substitute this A with a BA in next substitution. Okay, so that's why I am substituting this A with a BA as per fifth rule. Okay, then I have to generate a A. Here you can see BB and A is already generated. Just I have to generate a last A. So that's why I am going to check whether this S having a substitution with a A. Now here you can see rule number 2. We can substitute our S as a A. I am substituting this S with a as per second production rule. So here you can see with the help of leftmost derivation, we able to generate this string. Okay, I hope you understand the derivation process. After a leftmost derivation, we are going to check with a rightmost derivation. So here you can see there is a small example with of a rightmost derivation. So we have to generate this aabbaa string with the help of rightmost derivation. Okay. As we solving as per rightmost derivation, we substitute our rightmost variable with a terminals. Okay. So I have to substitute this s as something like I can generate whether a or b a. So I am going to check in my production rule or a context free grammar. Is there any substitution for a s where ending with a? So here you can see there is only one substitution for a s where it is ended with a. Okay, that's why I'm going to substitute this second rule over here, and I'm substituting with the help of second rule s with a. Okay, now I already generated a and a over here. Okay, so basically we have to generate now a string. Okay, so that's why I'm substituting this a, which is something like able to generate the string a. Okay, now I'm going to substitute this a with a production rule 3, because with the help of this I can able to generate this string. So that's why I'm substituting this as per my third rule. Okay, then you can see s and a, these are both non-terminals. Okay, so we are able to substitute these both of them. Okay, now as we solving a rightmost derivation, we have to substitute this a with a their substitutable value. So that's why I am going to substitute this a, as I already generated a value and b over here you can see. So that's why we have to generate only BA value with the help of A. Now I'm going to check with the help of A substitution, any of the substitution, any of a grammar value which able to generate a BA. So here you can see with the help of fifth, we can generate BA value over here. So that's why I'm going to substitute this A with a BA as per fifth rule. Okay. Now at this position we already generated A, B, B, A. So almost part we are done with that. Now only A have to generate. Okay, so that's why we have to substitute this S with a A. Okay, now check for now check in a production. So basically with the help of second production we able to generate a A. Okay, so I hope you understand the derivation of rightmost derivation as well as leftmost derivation. Okay, that's it for today's session. If you found this video helpful, don't forget to like, share with your friends and subscribe my channel. Thank you.